Hey guys, in this video I'll tell you the problems encountered while designing a slab in STAAD PRO. Basically, 99% of the problems that is created due to the inappropriate external meshing of the software. The clever way that ETAP solves the solution is how they meshes the slab internally. I hope one day STAAD PRO will also get the design of slab in a proper way. Okay, before that I'll show you the problems. But now I'll tell you the basic overview what's happening right there. Basically, if we divide slab in STAAD PRO, nearby beams will also get divided. Basically, even though we don't need that divisions on beam, still they will get divided. If they didn't divide, the load will be transferring from the slab to beam, which will lead to inappropriate bendings in beams. So rather not to say, I'll show you what's going to happen if we design a slab in STAAD PRO. Basically, I don't recommend design of slab in STAAD PRO, as that will give you inaccurate results of bending in beams and inaccurate moments in STAAD PRO. So let's get started, और चलिए शुरू करते हैं. Okay, man, it's very hard to understand which keys where. Alright, okay, so let's get into here. Gonna start a new model. Okay, right now, right in grid, I'll be trying to keep the ground horizontal. So I'll be keeping up the grid horizontal, and I like to take a beam. I don't care about the size, so just let me pick up random points right here. And I like to infill a beam plate right inside, so by keeping up infill plate. And right now, by picking up the node cursor, I like to convert this into a column by making use of translate repeat in the height of the column and linking the steps right here. Alright. Now, right now, let me give them a support. So either I can go right from here, so just create and assign a fixed support right here. Now you know that there's a plate right there and there is perimeter beams right here. Okay, without dividing, so let me just take a copy of this set. So I just want to get into translate repeat, and maybe gonna go right next to 10 meter. Okay, so that's right here. So we got two elements right here. One I'm not going to mesh, and the second one I've tried to get into here, and oh man, I didn't select this slab. Next it can be 10 meter. Okay. Okay, the next plate I'm going to mesh it, so maybe meshing right into 10 by 10 part. That is okay. As you can see that the first part, the beam is properly aligned from point A to point B, but in the second case, if you closely observe that the beam has been divided right into many sections right here, which is not at all an appropriate idea and not at all required. Alright, the next thing that I'll like to do here is I'll be providing maybe some load other than self-weight. We don't want to give the self-weight, so I'll be providing a UDL on plate. Before that, I like to assign certain materials onto this, so I'm gonna take a concrete section, so maybe the size can be like 0.5 and 0.5. Okay, and I'll be assigning that concrete section to the entire set, so you can see that this one is properly aligned, but right in this case each and every sections of beam is divided. So if you try to understand the distance by getting into node, let's understand the distance as the first point and the second point. So this is 0.5 meter, which means that much short the beam is, but right in this case, if you understand the size of the beam, that is absolutely 5 meter, which is what we want for the design purpose. Alright, that's all about sections. Then if you want to assign the thickness to the plates, so maybe 12 centimeter, I'll assign it to the view. Assign it to the view. That is also alright. Now let's get into loading. As told, I'm not providing any sort of self weight. Maybe a case of dead load, whatever, I don't care the name. Right into this case, I'll be adding a plate load right in. So maybe get into plate load, I'll be providing a uniform plate load of maybe negative 2 kilonewton per meter square in any global y-axis, which is probably the gravity direction, and I can assign it a set right into the view, and that is all what you can see. The first figure, the load has been applied into the perimeter, even though if it's a display representation. The load has been distributed inside the perimeter. Actually, the load will be right there in the internal part of the slab too, so we don't want to worry about the load case distribution. Now let's get into analysis command. I don't want to take a printout of anything, and right now I'll be designing stuff, and yeah, that's it. Now what I can do here is I like to get into post-processing, and first thing what I'm going to do here is I like to understand the displacement of the structure. You can see that in the second case the slab is dividing, and in the first case no deformations are there. So it's quite important fact that if you want to displace the slab, you want to mesh it. Meshing is quite important. If you ignore meshing, slab won't bend, will be just like a rigid diaphragm. Alright, okay, then you just probably understand what happened here. Okay, now that's all about the displacement. No meshing, no displacement. It's quite a simple algorithm. Now let's get into the support reaction. That so just listen that the support reaction is minus 10 kilonewton. So let me tell you how the support reaction come into this earth. I'll show you that my tablet is not responding. Come on guys, just hold on. Oh well, the support reaction, as you can see, that is a minus 10. So I know the area of the slab is 20. Okay, the load which I have provided is, I think it is 2, and the total number of support is 4, so this one will be 10. This is simple math on how you got support reaction. So basically, if you ever applied any type of certain load right into this slab, that will be always creating a bending moment. As you can see that this is a slab, and if you applied any load right onto the center, that will eventually put a dip right into the center, which will eventually create a moment which is not displayed right in any case. You can see all the moments are being 0, which is absolutely absurd. I can't believe that moment cannot be 0. But right into this case, if we meshed it, the displacement will occur right into this direction, which will eventually create a rotating effect here and rotating effect here, and which can be believed that moments will be always present. And also the support reaction is also there, which is obviously 10. Apart from the support reaction, we will be having a couple of force in x direction, which is caused due to the dip and the moment. So the second point also states that this is accurate and this is correct and this is exactly what we want. So if you ever happen to provide any bending right in, you have to provide meshing. So this is the second statement, that support meshing is required in the software. Now let's see some other thing. Okay, don't want to see the moment. Okay, then we are having the beam forces right there, and hold on control and rotate it. As you can see, the first figure doesn't provide any sort of loading. The beam is absolutely showing nothing. So let me check the graphs right here. If I select this asset, there is not even a single load acting onto this beam. Basically, the purpose of beam, which is used to capture the load from the slab and transferring it to the column. But right in the first case, if it didn't provide any sort of meshing, there is nothing existing onto this beam. There is not even a single load, no moment, no shear, and no axial force, which is very sad. Come on guys, this is very sad. Now let's see the column. Column will be having an axial force of 10 kilonewton, which is what we saw in the support case. Well, so the first one is crazy. If you're providing slab, please mesh it so that you won't see this type of blunder. I don't understand. Alright, now so that's all about the layout or graph, and now you can see that there are moments acting and there is axial force and shear force acting onto this. And also the main problem that I just want to show you is if you select a beam right there, this is not a single beam. These beams are splitted based on our meshing pattern, and we don't want to use this part. So if you want to see the whole bending, neither A nor B support our argument. So practically this is impossible. If we put up a slab in STAAD Pro and mesh the slab, we are not going to get the proper bending moment of the beam AB, which is right here and which is divided right here. So if maybe you might think that if you select all these beams 1 2 3 4 5 6 7 8 9 10, do you think this will happen? No way. What is this diagram then? This is the bending of the first asset. So I hope you understand what's the problem right now. Alright, now let's get into the design section. So I hope this is the main problem that we face during the analysis, and now let's see what's happening in the design part. First, I like to change up the unit right to Newton millimeter, and after, let's get into design. Okay, get into design, and I like to put up concrete. Code is okay. Now you'd like to define the parameters. So first, I want to just select the parameters like I like to give the compressive strength of concrete, just like that. Define, and this one can be like M35, and I'm not picking anything based on diameters. And I like to assign this to the view. You get into commands. I like to design the slab, and I like to design the beam. Okay, I don't want to design a column, so element assigned to view, element represent our slab. Now let's design the beam. So I'm gonna select the beam and like to assign to the selected part. Okay, that's all. Now run the analysis and let's see what's happened right in the output file, where you can see all of the outputs. So you can see there are 41 warnings, and the 41 warnings says that. Alright, before I join up anything, I like to pick up the beam number, shift bin B. So we are expecting the proper design for beam 1 2 3 and 4, and you can see that a beam from 11 to 30 50. So these are actually a single beam which is being split right into multiple beams. Actually, we don't want to see that, but still let's see what's happened right here. So what is this? This is the area of slab. So the element 5, so let's see the plate element 5. So shift and P for plate number, element number 5. So this is element 5. We are hoping exactly a proper design result will be there for that element. If we didn't mesh it, design of slab will be there, but how the surrounding structure behave to this slab will be a slight issue that's shown as warning. Okay, the longitudinal reinforcement and transverse reinforcement are alright. Okay, so if we scroll down a bit, if we get into design of beam, we are not getting even any area of steel right there. So if the length is 4 meters, the beam number 1, so this is the result of beam number 1, you are not providing any area of steel right there, which is also crazy. And you can see that even though they are not providing any area of steel, it got a particular 7 numbers of 10 diameter bar there. That is not going to happen. I don't believe that. Oh, but just wait, let's see the comedy right there. So if we scroll a bit, so if we, I think let's see, the beam number 4 is there. Now let's see beam number 5. Okay, this is a beam number 5. The length of the beam is 400 millimeter, which you can predict right into your hand. This much is the beam, and end of this beam is having support, and that is having a reinforcement right there, and that is also having an area of steel right there, and you can see the warning is right there. The length to depth ratio of member is less than 2.5. What are you trying to say? Conventionally, if we took up a beam right there, and there is a B, and there is a D, and there is an L, obviously L shall be greater than B and D. So right into this case, they're saying that L by what? L by D is less than 2.5. Alright, so the length is less than depth in the 2.5. Alright, length is, you can see, I think the length is 400. The length is 400 is less than what is depth was 0.5. Alright, we are now going to get this calculation. So if this asset is going to happen, STAAD won't design a beam. So if probably one way to solve this problem is not meshing the slab. So if we didn't mesh the slab, you saw what happened, and if we meshed the slab, you saw what happened. So I hope that someone will, STAAD Pro or Bentley, come up to this video. Please make a solution for this problem. And if anyone is watching, thanks for watching, and I love you.